we need to set up an iterated integral for this triple integral where the region E is above the triangle with vertices. So let's draw this triangle in the xy plane. So we got 0 0, that's the origin, 1 0 and 1 1. So we have this triangle, 1 1 here. Above this region D, we say on xy plane, and below the graph of g equals x squared plus y squared. Okay, so this is in fact the cone, and we want to evaluate this, but the calculation will be just like calculus 1 once we set up an iterated integral. So this triple integral always 20y dv is same as we're going to make double integral in D in the xy plane, and inside now we write just in terms of dz, where the function is 20y, and this on this region we have area dA. And let's first find the bounds for z. It says above the triangle, that's in 2D, two-dimensional, so z 0, and below the graph of g equals x squared plus y squared, so that goes on the top, x squared plus y squared. Okay, next we need to write this d. Now we have two options. If we take this going up down, then x goes from 0 to 1 and y goes from here, that's y equals 0 to this line. Now we need to find the equation of this line, y equals mx plus b, and we know the slope is rise over run, which is 1, and it passes through the origin, so there is no y-intercept, that's b equals 0. So this equation of this line is in fact y equals x. Okay, so we can come back here and don't have to put parentheses, but this is doing first. G equals 0 through x squared plus y squared, 20y dz inside. Now this goes up down and the x ranges from 0 to 1. We write dy dx like type 1 if you know the types, and here x goes from 0 to 1 and y goes from lower curve 0 to upper curve y equals x. Okay, if you want to evaluate, this is it. If you want to evaluate, then you can integrate 20y with respect to z. In fact, 20y will be a constant, so 20y z, and upper limit, lower limit, then integrate with respect to y, and upper limit minus lower limit, then finally integrate with respect to x. Okay, if you don't like dy dx, then this is, if you want to make not this way, there is an option. Then okay, you want to go this way, let's see, this way. So I'm going to write z no matter what first, then alternatively we could have written in this way. Inside is z equals 0 through x squared plus y squared, whatever the given function is, 20y dz. Outside, let's say dx dy, then y goes outside. For this, y can be taken anywhere here, 0 to 1, 0 to 1, then x inner. So look at this arrow, this curve to this curve. The left curve is y equals x, which is same as x equals y. So this is x equals y. To right curve is a vertical line which has equation x equals 1. So this should be 1. If we evaluate this or this, the final result will be the same.